Okay, I'm just going to go over a couple of these questions here from the Google form that is due later today. Question 1, I sent my boda driver after 17 moles of water. He came back with 283 grams of water. Should I pay him the full amount? Yes or no? So I've got the problem laid out here. We got water. I asked for 17 moles. He came back with 283 grams. So what we need to do is calculate how many grams are in 17 moles of water. So our first calculation is the molar mass of water. So I looked up on the periodic table the molar mass of each of the individual elements, and hydrogen is 1.00784 grams per mole, and oxygen is 15.994. So since we have two waters here, or two hydrogens, not waters, I'm going to multiply by 2. So if we take 1.00784 times 2 plus 15.9994, we see that the molar mass of water is 18.01508 grams per mole. So now the problem's simple. We want to find out how many grams, so we're going to multiply 17 moles times 18.01508 grams over every 1 mole. Our moles will cancel out, and 17 times our previous answer here is 306.256. 306.256 grams of water is what I requested. Now, if we're going to round this to significant figures, we have two significant figures here. So we should round to this point because 3 is our first significant figure. We look at the 6, we're going to get 310. We have to put that 0 so we don't change the value. It does not just become 31 grams of water. So we get 310 grams of water. And then we compare, and we see that our boda driver only brought us 283 grams of water, and that's not enough. So we should not pay him the full amount. The next question we're going to look at is question 2 here on the form. How many moles of F2 are there in 12 grams of F2? Okay, so again, I've already looked up the molar mass of fluorine. A common mistake here is people would say that the molar mass of fluorine is the molar mass of F2. It is not. It's a single monatomic fluorine. So diatomic fluorine, we have to take that number times 2 to find our actual molar mass of F2. So 18.9984 times 2 gives us 37.9968. Grams per mole of F2. Now we already have grams, so that means that we want to get rid of grams because we are searching for how many moles of fluorine gas we have. So we got 12 grams times 1 mole, because that's what we want, over 37.9968 grams. Our grams then cancel out, and we get 12 divided by our previous answer, which is 0.31581. Okay, so we have two significant figures here, so we're going to round to the second spot. 0.3. Now we look at this number, we see it's a 5. And our rounding rules for 5 is round to the even number. So we need to round to 3.2 mole or 0.32 moles of F2. If this number was 32581, this is a big if, we would still round to 0.32 because this 5 would make us round to the even number. Just significant figure rule reminder there. And the final problem we're going to look at is I was sanding rust off of my car and removed 87.3 grams of iron 3 oxide. How many moles of rust did I remove? So we have 87.3 grams of iron oxide. We are looking for moles of iron oxide. I looked up on the periodic table, mass of iron 55.845. We have 2 atoms, so we need to multiply by 2. Oxygen's 15.9994. We need to multiply by 3. So let's go to our calculator. 55.845 times 2. Let's put that in parentheses. Plus 15.9994 times 3. I should have put that in parentheses as well. Equals 159.6882. So we have 87.3 grams. We want to multiply, this is grams per mole. We want to multiply by 1 mole for every 159.6882 grams. Our grams will cancel out and we will end up with moles. And our answer is, so we're going to take 87.3. We're going to divide by our previous answer. We're going to get 0.54669. Moles of Fe2O3. Now our problem gives us 3 significant figures. Our periodic table gives us more than 3 significant figures, so we need to round this to 3 significant figures. So we're going to round it to 0.547 moles of Fe2O3.